Section 2.4 talks about different special cases about solving equations. So sometimes we have one solution to an equation, which is what we've already done. Other times we may have an equation that will never work, and that's where there are no solutions. And a third situation is where we have an equation that will always be true. That is called an identity, and there are infinitely many solutions. So let's take a look at our notes. The solution to an equation is the value of the variable that makes the equation true. So if we have an example of x plus 3 equals 8, the solution is x equals 5 because 5 plus 3 equals 8, which is a true statement. Sometimes there is no value you could plug into an equation that would work. When that happens, we say there is no solution. We will see an example of what happens when we solve an equation that has no solution. Sometimes we can solve for a variable and we end up with a value that works, like the example where x equaled 5. The problems we have done so far this year have had one solution. And the third case is where there are equations that will work no matter what value you plug in for the variable. These are called identities, and we say there are infinitely many solutions. So we have seen many examples where there is one solution. Again, all the work up to this section have had one solution in the equations. So let's take a look at examples of the other kinds. Down here I have 8x plus 12x minus 10 is equal to 5 times the quantity 4x minus 10. So we follow those same guidelines to solve equations. So I'm going to draw my line where the equal sign is. And the first thing I'm going to look to do is use the distributive property. I see the 5 in front of parentheses, so that means I'm going to distribute the 5 to the 4x, and I'm going to distribute the 5 to the 10. So on the left-hand side I haven't done anything, so I'm going to copy that left-hand side down, 8x plus 12x minus 10. And on the right, I'm going to take the 5 and multiply it by 4x minus the 5 times the 10. So let's simplify. So we have 20x minus 50. And on the left-hand side, I'm going to copy it down, 8x plus 12x minus 10. So that was using the distributive property. Now my next step is to look to see if I can combine like terms that are on the same side of the equal sign. So I notice that I have 8x and 12x on the same side of the equal sign. So I'm going to combine those to be 20x. So these two here combine to be 20x. Copy down the minus 10 and copy down the other side, 20x minus 50. So I've done the distributive property, I've combined like terms. Now the third step is to get the variables on the same side. So I need to take this 20x to the other side, so I'm going to take away 20x. So I'm going to subtract 20x from this side. What I do to one side, I have to do to the other, so I'm going to take away 20x here. And now, some people might get confused, because 20x minus 20x cancels here, and the minus 10 is still left. On the other side, the 20x minus 20x canceled, and I'm still left with minus 50, or negative 50. Here I have negative 10 equals negative 50, and we all know that that's not true. So I ended up with a false statement. So I'm going to put in real big letters, false. Negative 10 does not equal negative 50. When I end up with a false statement after my variables disappear, that means there is no solution. So again, when you end up with a false statement after the variables disappear, there is no solution. Let's take a look at example 2. So I'm going to do the same process. So we're going to draw the line where the equal sign is. We're going to start with using the distributive property. So I notice that 3 is in front of parentheses here. So I'm going to distribute the 3 to both the 3x and the 2. I don't distribute the 3 to the 41 because the 41 is not in parentheses. So it's going to be 3 times 3x plus 3 times 2. I distributed the 3, copy down the rest of the problem. Alright, and then I'm going to figure out what 3 times 3x is. So that's 9x. 3 times 2 is 6, plus 41. Copy down the right-hand side of the equation. And now it's time to move on to the second step, which is combining like terms that are on the same side of the equation. So if I take a look at the left-hand side, I see a 6 and a 41. Neither of those have variables with it, so that means that they're like terms. 6 plus 41 is 47. So the left-hand side becomes 9x plus 47. On the right-hand side, I have 14x, and then be careful here, there's a common mistake. A lot of people say this is 5x, but it's actually minus 5x. So it's 14x minus 5x. Let me circle those. 14x minus 5x gives us 9x. And then I also have a positive 3 and a positive 44. So 3 plus 44 is 47. So I'm going to underline those. Plus 3 and plus 44 is plus 47. Alright, so I have combined like terms. My next step is to get the variable on the same side of the equal sign. So that means I have to take this 9x to the other side, so I'm going to subtract 9x from both sides. And when I do that, I notice that these 9x's cancel, so I'm left with 47 on the left. And these 9x's cancel, and I'm left with 47 on the right. Now if I look, the x's went away completely, and I'm left with 47 equals 47. Well, that is a true statement. So when this happens, where the variables disappear, and I'm left with a true statement, that means that it's an identity. An identity means that no matter what value you plug in for x, it will always work. So we say that there are infinitely many solutions. And I'm going to abbreviate solutions with SOLN apostrophe S, solutions. And that is basically the idea of the special cases. So when you solve an equation and end up with the variables canceling each other out, you just look to see if it's a true statement or a false statement. So the big idea, when you solve equations and try to get the variables on the same side, but when you do that, they cancel on both sides, then there is no solution, if you end up with a false statement, like -10 equals -50. If you cancel both sides and there's no variable left, there are infinitely many solutions. If you end up with a true statement. And those are the notes for section 2.4. So on digits, you will just have to choose one solution, no solutions, or many solutions. But on your paper, you have to show the work and explain how you knew what the correct answer was. Good luck!